Hello. I think we should be online right now. I'm hoping that the others are going to confirm that. Hi everybody. We're back. It's Lambda Lounge. I'm James. I'm sure most of the people who go to Lambda Lounge have probably worked out who I am by now. And yeah, we're back. We've got a few talks for you lined up tonight. I'm going to just scroll in. But first, before that, obviously, in these strange times that we're living in, actually speaking to each other has become rather difficult. And as such, we've decided to give having a Discord server a go. Please come along and join. So if you already have Discord, you should be able to just scan that QR code. If you don't have Discord, then the link that's at the other side should let you in to the Discord for us. The key thing to say there is that it should drop you straight into the rules channel. Read the rules, and then there's a little sort of thumbs up emoji on the bottom of the rules. And if you click that, it kind of changes your permissions once you've accepted the roles, and you can see the rest of the server. We'll all be on the Discord after all of this, so if you've got any problems with that, we'll try and rectify that, or let us know if there's anything wrong with that. We're still working all of this out, obviously, as I'm sure everyone is really. So yep, that's kind of that. So we have 3 talks. Three talks and this bit, which is the opening bit. First, we've got our own Connor, and he's going to be comparing Scala and Kotlin, which should be pretty interesting. If you have any questions as well while you go, please do put them in the YouTube comments in particular, because we can bring the questions up from the YouTube comments if anyone has them, put them on the screen. So we'll do that, and then there may be a short break while we just kind of fiddle with the bits. And thank you for commenting, whoever you are. Greg, I can click the button and show someone said something. Thank you very much. That's really useful for the demonstration. So yep, we can do that. That's all good. After that, we'll have Andrew, and he's going to talk about some TDD in Clojure stuff. I think there's also something around REPL-driven development, that kind of thing. So if you've got any interest in Clojure, that should be good. And then finally, we've got Jorge talking about lessons from doing production FP. Just as well to say, I just want to give a sort of big shout out to Codurance and Jordan Robinson from Codurance, because they've helped us out for just sorting this out, finding speakers. They're not sponsoring us this month. They usually are our sponsors, but they've been their usual wonderful selves. So thank you very much, Codurance. Yeah, I think that's about it. We're way earlier than I expected, which was what I thought might actually happen, but oh well, such is life. I'm going to bring Connor in. Hello, Connor. It is you.
Hello, James. How are you? I'm good, thanks.
Yes, absolutely.
It's good to have the internet.
Yeah, isn't the internet brilliant?
It's good.
What a fantastic invention. I think, trying to think. Oh, hi Jordan. Do you want to start? I think maybe we should get going.
Yeah, I can do. Anything else we need to do first? I think that's all the slides you want to run through beforehand, right?
Yeah, absolutely. I think there's nothing else. I'm worried that, as I say, we're going to be really, really too early, but it's difficult to gauge all this kind of stuff. Okay, I think I'm gonna chuck my screen out and put your screen in, and we'll see how that goes.
Cool.
That worked well.
Okay. Very good. Okay, I will get started.
You get going. I will leave it to you, and I'll be back once we get to kind of questiony time.
Cool. Right. Okay. So hello everybody. You might remember me from Lambda Lounge in the past if you've been before. Otherwise, hello. I'm one of the organisers of Lambda Lounge, along with James, Hakeem, and Alex and Sam. So this week, or this month rather, I'm going to talk about Kotlin and Scala, because finally I got paid to write every single major JVM language, which is great. So now I can compare them and not sound like a fool, at least mostly. So just moving on a bit. So you may or may not have heard of Kotlin. If you haven't, it's a JVM functional language, yay, which is why we're talking about it here. Developed by JetBrains. So there's obviously really good support in IntelliJ for it, but you can obviously use other IDEs as well if you like. So it's officially supported for Android apps, has been for quite a while. You can also target JavaScript and native code by LLVM if you wish. And yeah, the interop with Java is really good. I think it's one of the kind of key like points for the language, that it should be really easy to interoperate with Java. So that's all good. And of course, Scala. Well, what's Scala? It's another JVM function language developed by someone who wasn't JetBrains, Martin Nadrowski and his chums in Switzerland. It's not officially supported for Android, as far as I know, but it can also target JavaScript and native code via LLVM. And you can also do interop with Java, though it's not quite as easy. So you might be thinking, this looks remarkably familiar from the previous slide. Well, that's the whole point. I suppose the thing I found when I started doing some Scala was how easy it was to pick up, knowing Kotlin. So I think I thought it'd be cool to just compare the two, Kotlin and Scala, just to kind of give a flavor of both. So like if you know one, I think it's pretty easy to pick up the other, and you might find it useful. So let's go on kind of a whistle-stop tour of the bits that are the same and the bits that are not quite the same. So on to the next slide. Cool. So it's pretty much a bigger thing that you have to start with hello world. So there you have the Kotlin version on the top, Kotlin hello world. You can see the functions defined with fun, which makes Kotlin instantly more fun than other languages. But it uses this variable name and the type. And you got your print line hello world. And the Scala version down here, but looks remarkably similar. You just have to use def instead of fun, and also it's just this assignment to the braces type thing. So right off the bat, they look very similar. They don't have the same variable style as Java. They both have the same one. So they're I would kind of describe them as similar but a bit different. So I mean, they're both functional. They both encourage you to use immutable data a lot, as much as possible, which is a good thing, obviously, because it makes reasoning about your code a lot easier if you have state being mutated left, right, and center. You can both leverage existing Java code. You can call Java libraries from them, or the JVM as a platform generally, which is good. Both are folds without needing another library, which is my #1 thing for functional languages on JVM. Java, of course, has stuff like Vavr, which you can use that let you do that stuff, but it doesn't come out of the box. But they do have some different design decisions. So let's have a look at some. So this is some of the stuff that is more or less the same. So if you have a class, myData, and if you do def myprop, this is Scala, by the way, def myprop, which is a function that returns the value of prop. If you instantiate that in Scala, you don't need to put the brackets on. You can just do d.myprop if it doesn't have any parameters. But in Kotlin, it's a little bit different. So the way you do things with Kotlin generally is that you don't tend to write getters and setters by yourself usually. But if you want to have some special behavior, you can write it like this. You basically define the variable, or field rather in this case, and then do your getter or setter afterwards. But you can see the syntax looks pretty much the same as Scala's. And another thing that is in both languages, but again, is a little bit different between both. So for Kotlin, you have the anonymous parameter it. So anytime you use a Lambda parameter, if you don't want to bother specifying the parameter, then you can just do it. So if I have some integers that I want to square, I can just do my_int.map it times it, and that will square them all. Scala, you can't do that. It's a little bit less flexible for that. So you have to define the Lambda with the parameter itself. So it does have the anonymous parameter there, but you can only do it once. So if you have something like that, my_int.map, _my_method, which I find a little bit not as nice in Scala. I kind of got used to the convenience of having the anonymous parameter there without me having to kind of go to the whole rigmarole of defining the Lambda myself. So on to the next slide. So data objects, like I said before, immutable data and data objects are kind of a big thing in Kotlin and in Scala. So you can get this stuff in plain Java. if you use something like Lambda, for example, you can do data classes there. But it's kind of baked in to both Kotlin and Scala, which I think is really nice. This makes it really easy to have immutable record classes that you kind of just you don't mutate their state. If you want to make a new one, you just do item.copy and then change the parameters as you go. So you can see in Kotlin it's called a data class, and you got your parameters here. You do have to tell it what the mutability of the variables is. In this case, it's val because they're immutable. In Scala, they're called case classes. So you have case class, blah, blah, but otherwise they work pretty much exactly the same. I have to say I don't know why Scala calls them case classes. So if anyone does know, please put it in the comments. So yeah, and then I'll say it, and I'll learn something. So that'd be good. But I think I found that data classes or case classes are a really useful thing. Once you start using them, you'll think, wow, how did I ever get by without this? So they got a big thumbs up from me. So next slide. So this is where kind of Kotlin and Scala diverge a bit. So the $1 billion mistake is some guy, I can't remember his name, famously described it. So this is nulls. So this is pretty different in Kotlin and Scala. So basically in Kotlin, you have to explicitly say whether a function will return a null value. So you do that by saying like say you have a return type t that you want to return back from your function. If you have the return type of t, you're asserting to the Kotlin compiler, this will never be null. It'll always have some value. If it can be null, then you have to do t question mark. And if you get it wrong somehow, then the compiler will complain. It'll say, well, you made a mistake here. You said this was never going to be null, but wait, you've done something stupid. It's null here. So that is good from the point of view of making sure that you don't make mistakes. But it slightly has a problem with Java interoperation because most of the time Java code doesn't indicate whether this is true or not. So you get what's called like a platform type, where it goes, it might be null or might not be null. Might be, can't tell. Unless you have like not null annotations on the Java code, in which case it does figure it out mostly. So Scala, of course, uses the option monad. I said the M word. So basically, you have a box which contains a value that might be there, it might not be there. It's like Schrodinger's value. And I have to say, I do prefer that approach just because I prefer to kind of have an option that I then kind of can map or flat map or filter or whatever, rather than having to say, okay, well, I got this value that might be null, and you end up using in Kotlin the Elvis operator, which if it's question mark colon, it's like a bit like a ternary, but yeah, more weird looking. So yeah, you can see here's an example. So if I'm getting something out of a map in Kotlin, map to get my key. So it might be null or might not be there. I don't know if it's there or not, basically. I can't tell. So you can use this question mark dot syntax to say, if it is there, then get my prop. And then the Elvis operator, you have to tilt your head to the right, and it doesn't really work in this font, but you can do it at home. It looks a bit like Elvis. If the thing on the left is non-null, it'll give you that. Otherwise, it'll give you the thing on the right-hand side. But of course, in Scala, it's an option, so you do your maps and getter s and so forth. So I do prefer that approach. I don't really like the kind of whole kind of shadow or parallel type system that Kotlin's go down. But you can get options somewhere else. Okay, so operator overloading. So this might not be strictly the right term, but when I say operator overloading, what I mean is you can give special meanings, I suppose, or you can define some function to happen when you use a predefined set of operators, like a plus or a minus or star or whatever, which is nice. It kind of makes sense. For example, like say you have two lists, you want to have the plus operator be concatenated together. That makes sense. That's nice. You can also do infix functions as well. So if I have a function here like infix fun int.map, that's basically saying, please define an extension function on int that takes in an int, and then it can do some stuff. And I can use it like this, one myop2. So that's the same as saying one dot myop brackets 2, but it looks more infixy, which is cool. So extension functions are a bit like Scala implicit. So I can't say I understand Scala implicit perfectly, but As I understand it, you can kind of declare that a type will be kind of implicitly converted to another type that has some certain extra methods and so on that you can use. So that's kind of like, yeah, just go crazy, do whatever you want. It's cool. You don't have to have any kind of syntax, whatever. You can define methods like this, colon, yeah, fine. This is just my outside perspective, not having done a massive amount of Scala. But I think it's a step too far myself, because you end up having loads of weird looking code with operators you have to kind of hunt and find the meaning of, which to me it kind of hurts readability, I have to say. Yeah. So let's move on to the next slide. By the way, feel free to disagree with me in the comments. I won't mind. You can tell me why it's a really good idea to have this stuff. Cool. So pattern matching. So this is the thing that Scala has big time over Kotlin. So Kotlin does have sort of pattern matching. It kind of does it for most of the kind of common-ish use cases, perhaps, that you might want to use pattern matching with this when block. So basically, it's kind of like a switch statement on kind of steroids. You can do like extra stuff, like when person name is equal to Jim, do that. When X is odd, do that. Else, do that. So it's quite nice. Most of the time when you do stuff, then it works fine. It does the job. It does tend to neaten up your code, which is good. But Kotlin, or rather Scala, you can do much more powerful stuff with pattern matching, which is a real plus from kind of a writing code point of view, which is something that Kotlin misses out, in my opinion. Cool. So just talking about async code. So this is another one where the approaches are fairly different. So Kotlin has coroutines. So if you haven't run across this before, that basically is like a kind of lightweight thread, I suppose, that you can kind of suspend. So just at a very, very high level, I suppose, you basically just mark your functions as suspend functions. So you'd have suspend fun, whatever, do my thing, that happens to be async. And then you can then, those functions kind of can suspend themselves. And in general, it works pretty well. From the point of view of running kind of async code. It's nice. You do have to think about it a little bit. And it is kind of slightly difficult, in my experience, to get your head around the first time you do it. At least I find it a bit difficult. A Scala doesn't have that, as far as I know. Don't prove me wrong, please, if it does exist. But it does have features like a bit like the Java features, I think. And it's big on the actor model with Akka. So just like from my perspective, the actor model is it works fine. It's the Erlang kind of thing where you send messages to different people to do the thing and then come back and tell me when you're done, which is good. But I suppose it also means that your code is shaped a lot more by the concurrency mechanism you're using, which you might think that's a good thing, you might think it's a bad thing. I kind of would prefer that it kind of stays out of the way most of the time if possible. But you do get kind of some other stuff like the concept of supervision hierarchies and stuff, which is quite handy. Cool. So other stuff, other stuff. This is just like a catch-all for the other stuff that we got going on in Scala. So Scala, I think, has the reputation of being like an academic language, or at least a more academic language. I think Kotlin has the kind of perception of being a language that people use to get stuff done, which is fun. But like Scala, if you want to do stuff like higher kind of types, or kind of point-free code, or like have loads of monads, then you're going to want Scala probably. Although of course you can get those things in Kotlin. There's a really good library called Arrow that has a whole bunch of stuff like try or either and that kind of stuff. So you can do this stuff. It just doesn't come. It's not a batteries included kind of thing, I guess. So I guess it's a case of, to me anyway, it's like, will I need the stuff right off the bat, or will I, add it as and when I need to? So, or do I kind of want to rely on the library? I suppose the good thing about Arrow is that the developers seem to work quite closely with JetBrains. So a lot of the stuff from Arrow seems to be kind of, or appears to be on the roadmap for being kind of incorporated into Kotlin in the future, which is nice. So And I think that's pretty much it. That's the end. Yes, that's the end of my presentation. So basically, I think the key takeaway is that if you understand Scala, it'll be pretty easy for you to pick up Kotlin, and vice versa. If you know Kotlin, you'll probably be able to be productive in Scala within like a day or two, which I think is good. Just don't get put off just because Scala has the reputation as like an academic language that's like crazy difficult and full of like monads flying everywhere and stuff like that. Don't see it that way. You just kind of give it a go. It's not that bad, and you can get useful stuff done, especially if you want to do stuff like Spark, or whatever, where kind of Scala is a first class citizen. Yeah, that's pretty much it. So got time for questions. James, do you want to come on and read some questions out? So I can try and answer questions.
I can do that. Yes, I've been posting all the Scala memes as the Lambda Lounge channel in the chat. That's
very good.
Professional.
I can't promise to know the answer to any of the questions, but
yeah,
I'll try my best.
I'll answer the Scala questions. That's fine. Okay, let's have a look. So there was a mention. There was some talking about I can do this. This is all very fancy. There was some mention about TypeScript and how kind of Kotlin's similar to TypeScript. I think there's some of that in there. Yeah.
Maybe I've done some TypeScript, but not a massive amount, I'd say.
Yeah.
You get more belt and braces stuff for Kotlin. Yeah, the solidity of the JVM. Who doesn't love that?
Yeah, I mean exactly. I feel like that's one of those things where there's only so much design space around sort of putting the like classes and types, and it's got some functional ideas like map and flat map and stuff, so they necessarily end up looking a bit similar, because obviously TypeScript's kind of interoperating with JavaScript and Kotlin's interoperating with Java, so they kind of necessarily end up looking a bit similar. Let's have a look. Oh, I answered your question as well while you were saying it about why is it a case class and a class, and the answer is that a case class gets an apply and an unapply method, and that allows you to use them in pattern matching. So if you try and do pattern matching on a class in a pattern match, and you try and then get values out of that class, you can't do it because you don't have an unapply method. So you'll be able to match on the type, but you won't be able to use the extractors because you won't have an unapply method.
Oh yeah, I suppose that's something that has an analog, I suppose, in Kotlin as well, because the Kotlin data classes automatically implement the kind of component 1, 2, 3 up to n methods, so you can use destructuring to get the values out and do that kind of stuff. Yeah. So that's
exactly. That it's like similar mechanisms on similar takes on the same set of ideas, isn't it? Let's have a look. What else? Let's have a look. There's one here which I figure I'm just going to pick it out, and then something about, is there an init method as well as a constructor, and if so, what does that mean? I have no idea.
I don't remember, to be honest, what that might be referring to. I suppose I guess it might be referring to so Kotlin, as long as Scala it doesn't have the concept of like static variables really, like Java. So you got your companion objects going on in there. So that might be it. I'm not sure.
Cool. Yep. We'll do another question while we're sorting out. If you had the choice, would you rather program in Scala or Kotlin, and why? Oh, yeah.
Actually, that's a good question. Actually, which one is going to pay me more? That's the real answer. I'd say probably Kotlin, just because I know it better. Plus, I suppose I spent like a year doing Kotlin with a really good team, so like it's got good associations with me at the moment. So Scala seems pretty cool. I wouldn't mind doing some Scala.
Yeah, I think like even though I'm a Scala bod and do really like it, I wouldn't mind doing Kotlin either. To be honest, I think I'm sort of an apologist for the JVM, but I really like functional programming. So yeah, there's only 3 languages, or I mean 3 languages that people actually will pay you to.
Too if you hate yourself.
I suppose, but that you'd want to do and that people would pay you to do on the JVM. Here we go. I'm going to pick. How easy is it to create DSLs with Kotlin?
So you can do it. I know people have done it. So it certainly is possible to do it. I've not done it myself, I have to say, because I personally don't quite get the whole language-oriented programming kind of vibe. It doesn't. To me, it always seems like creating like a very specific thing to solve a problem that I would prefer to solve in a more general case. But it certainly is possible to do, because I know that there's an Elasticsearch library for Kotlin that uses like a DSL type thing. So yeah, it is certainly possible. Yeah. Any more questions?
There was a question asking about comparing it to Clojure.
Okay, yeah, I can do. Yeah, so I suppose the difference between let's just take Kotlin and Clojure, because like Scala and Kotlin are, you found the comparison in your head already. So obviously Clojure is a Lisp, so it looks way different. I think Clojure has a lot of stuff that Kotlin doesn't, and doesn't claim to have. So what Clojure is really good at, I suppose, is data processing, because of course it has that code as data thing. It also has like nice stuff like software transactional memory and stuff like transutions and stuff, which is like, I'm sure you could do it in Kotlin, but it's not like a batteries included part of the language, as it were. I think Clojure, I would say, just like from a kind of learning point of view, probably has a higher learning curve if you've never touched Lisp before. Kotlin, I would say, is easier to do if you've never done Lisp. If you know Java, of the two, Kotlin would be like a million times easier to learn than Clojure, I would say. I mean, but they're both dear to my heart. I love them very much. I did Clojure for a while at the BBC. That was really good. So it's kind of at the end of the day, it's about like which is the best tool for the job, really. Like if you're doing some like data processing, I would like probably go for Clojure. If you're doing like generic kind of making a web app, but you want to be able to do nice functional stuff, I'd probably go for Kotlin myself. So hope that answers your question, Squirrel Boy, whoever you are.
I have a guess who it is. Oh no, okay. Oh, good. The speakers are turning up. This is good. Okay.
Asia is not the third JVM language, by the way. Asia is not Asia. No.
No, as I said, 8 is cancelled. I've decided. I'm commented as Lambda Lounge. I'm sorry. I'm taking that. Okay, so I think.
Oh, and Alex, yeah, it is actually, yeah. Well, it is. Kotlin is still pretty object oriented, but you don't have to do it that way, because actually, all the examples I showed work in object related, but you don't actually have to do any of that stuff. You can just have top level functions and just go nuts with functions if you want. You don't actually have to have any objects, really, unless you feel like it. So don't let my examples put you off.
So we've got Andrew Whitehouse now online. I'm going to bring him in. Fingers crossed. Hello, is that Andrew?
Hi.
Yep.
Hi.
I'm gonna boot you off. Thank you very much, and I will speak to you soon. So thank you very much for coming on. I think basically feel free to take it away with your talk, and we should be good to go.
Okay, thanks. So I wanted to make sure I had good Wi-Fi this evening. So I've actually come into the co-working space where I'm usually working, but they're actually repairing the ceiling. And they've taken the handle off the door. So it was it's normally the Wi-Fi or other things, but a few other challenges. Anyway, it's good to be here. So I wanted to spend a bit of time talking about TDD in Clojure, and the rationale for this talk is I've been a software developer for quite a long time, been contracting since 2003, and I tend to move between Java and Clojure projects, and there's a perception that certain types of functional languages, people do all this cool stuff in the REPL, and that's one of the options which is available to us, but I just wanted to show that actually there is a more perhaps traditional workflow that exists, and I just wanted to talk through that. And there's another angle to it which I'll get to as well. So let me see. Sharing the screen. Look at these options. Okay, let's hope this works. Am I sharing?
Just 1 second. I'm just waiting for that to come up. Fingers crossed. I knew there was going to be technical difficulties the first time we ever tried this.
Right.
We're not. I don't have it on here at all, unfortunately.
Okay, so I can't click the share screen button now, so I'm
That's a bit what?
guessing it.
I wonder if I need to go like that. Try that.
Let me see. I'm just going to click around a bit and see if I can do the same thing and get a different result. So it's no, I can just see you and me at the moment, James.
Oh, rubbish. What browser are you on from? Sorry, everyone.
Brave.
That may be
Shall
the
I switch
issue.
to Chrome?
Yeah, maybe it might be worth switching to Chrome. Unfortunately,
Okay.
I dislike having to do that myself, but yeah, I think it may be the way forwards.
Right.
One second. Sorry.
Oh. Okay.
Apologies, everyone. This is our first time trying it with this software and doing all these kind of things. So
we're breaking new ground.
Yeah, absolutely. Aha. Okay, got another one of you now. That is good.
Right, so I'm just going to stop that one. And
yep, I'll stick the other one of you in. There we go. Okay, cool. That should be you from Chrome. Fingers crossed.
I'm just going to quit that one, actually. Okay. So let's try again. Share screen. Sharing screen is easy with 2 monitors. Right, let's try that. Okay, that looks more promising. So,
aha, I have a screen to be able to put in. And now cool. Infinite recursion, good stuff.
Yeah, okay. Got to start with that.
Absolutely. All right, I'll leave it with you. Thank you very much again for speaking.
Okay.
Cheers.
So, can you see some white letters on a black background? Okay, let's hope so. Can you see what look like slides? Can you give me a...
Sorry, yeah, I'll jump on. Yes, we're all good.
All right, thank you.
Yep.
Didn't want to just start talking without checking.
No,
okay.
It's all right. Yeah, go for it.
Great. Okay. So yes, as I said, so my background, I've been doing Java for some time, and then I went on a foray into functional programming. And I looked at Scala and I looked at Clojure. Both have their pluses, but I like Clojure because actually there's less to learn. To be honest, it's a simple, as in not compound, actually as in not complex as well, but there's actually less stuff to keep in your head, and it's a really productive language, particularly good for building APIs and also just data munging. So yeah, TDD and Clojure, even in Clojure in dynamic languages, and some might say especially in dynamic languages, we need to write automated tests. I have worked on projects where people can write the code in a REPL, and sometimes that's at the expense of tests. So particularly with my Java background, having the automated test and doing test-driven development is important to me, and it does seem to work quite well. So a bit about me. Afterwards, if you've got any questions, I'd love feedback on this talk to see what you liked and what you'd like to see more of or less of. I'm on the Clojure Slack, and hopefully that will be sufficient for you to find me. I've been contracting for some time, and currently I'm working for a company called MyPulse, who are a health tech startup doing video consultations, and we are hiring. So if you're looking and you're sort of mid to senior level, good at picking things up, we don't require Clojure, but a mixture of skills and the ability to learn new stuff is welcome. So why test? Well, as I said, we need automated tests to prevent regressions. And the particular focus of this talk is about showing a workflow which hopefully is familiar to you. And I've already said why I like Clojure. So I'm going to start with IntelliJ. So over to IntelliJ. We have in IntelliJ a plugin called Cursive, which is pretty good, and it gives us the integration with Linigan, which is probably the most established Clojure build tool for managing dependencies and running tests, and it also gives us nice syntax highlighting and a REPL. So I created this workspace by running the command line new project name, and what that gave me was a standard project structure. We have a source directory and we have tests, and I've modified the standard ones. So we have a failing test to start with. I'm going to go through a kata. The kata is the Roman numeral kata, and the challenge for this is to do addition on Roman numerals without converting them to Arabic numbers first. Why this is a nice kata to do is there's a history behind this. It always used to be the first item on the London Clojure Dojo board to get things started, but I don't think we ever actually did it. So quite a nice one to start with. So there's a few different steps to this. The very simple case to start with, when you're so I've written a test here, and the simple case is when you add two single Roman numerals together, as long as they're in the right order and there are no other complications that we'll come to. If you add 1 + 1, it's 2, and you can see actually it's a concatenation operation. So if I just do line test, so very simple way to get started. There are lots of ways of making this more complex. You can add in extra bells and whistles and have wrappers around it, and you can have there's a plugin called test refresh so that you can have it watching your code and it reruns the test when it changes. But the very basic thing, and the thing that's easy to get started with, is line test. So we have a failing test. It's saying we're expecting II, so 2, but we're getting an empty string, and that's because I implemented this function just to return an empty string, so the test was failing. So let's make this test pass. So here's our Clojure function. It's called Roman add. It takes 2 parameters, and there's no sort of return statement. It's just the value from calling the function is the last value in the form. So this is now going to return II. Hopefully make our test pass. Good. So we've got 1 test with 1 assertion and 0 failures. So let's now add another assertion in the test. So if we let's say we want to add 5 and 1, so that should be 6. Now I could run it from the command line, but I want to show you what it looks like running it from the REPL. And the reason why running it from the REPL is nice is, first of all, you can try stuff out. So if you're trying to figure out what something like in the REPL, you can just type it in. So the IntelliJ run configurations, when you're using Cursive, give you allow you to add a local REPL, and I set that up earlier to save time. So yeah, I can just evaluate. Let's see. Just evaluate something in the REPL, and if look in the tools menu, this tells me what options I have available. Some of them are grayed out at the moment. If I click in the test namespace, you can see now we've got some extra ones, and one of them is run test in current namespace in REPL. So I've got that mapped to Command Shift T. So if I run Command Shift T now, we now have a failing test, and it's helpfully highlighted the test which is failing. And if I hover over it, it says what I wanted was VI, but we actually got IO back, and that's because I hard coded the value. So how do we fix that? Well, the very simplest case for addition like this is actually concatenation, and one way that you can do that is just by calling the stref function. If I REPL, Clojure allows you to, in the REPL, you can use doc to give you the documentation of functions, and you can see it takes one or more arguments and yeah, basically concatenates them together. So yeah, this is going to concatenate the arguments which are both strings. So if I go back to my test namespace, that passed. All good. So I could carry on. There are like 3 more iterations of this kata, but I just wanted to show you that actually it's really simple to get started in IntelliJ, and you can use the REPL as well, which means you save the startup time of starting up a VM to run the test, so your feedback cycles are quicker. So that's IntelliJ. I wanted to show you something else which I think is quite interesting. Jupyter notebooks are traditionally associated with Python, and so let me bring up the other. Yeah, so they're traditionally associated with Python and data science, but you can run other languages in them as well. And one of the languages that you can run is Clojure. And what's nice about this is you can run code in the notebook, but you can also add Markdown to annotate it. So I think it's a really good way of teaching and learning a language. So what I've done is I've put some of the Roman numeral kata code in here. I just wanted to show you what that looks like. So we've already got our kernel running behind the scenes. So if I click in one of these cells and I do Shift Enter, that just tells me what namespace we're starting in, which is the user namespace. May not come as a big surprise. And there's a couple of things I want to bring in: the Clojure test namespace, so I can run tests, and also Clojure REPL, so I can get documentation about functions. So I'll just use those. Now, whereas in the other case, I had my tests and implementation in different namespaces, it's actually all in the same space here. So we've got the tests and the code all in one space, but that's fine. So I'm going to start by declaring this enclosure. It's called a var, but it's basically just a name for something. We're going to declare it so it's not undefined, but it's not actually bound to anything. So when I call my test, it's going to think about it. Defines the test. Okay, and then when I run the test, it says, okay, let me just clear this down. Try again. So it does actually hold on to the state from before. So I just need, because I was testing this earlier. Okay. So for the sake of time, I'm not going to restart it, but actually, no, I can. It won't take long. So I'm running it locally from a Docker container. So need to restart it and load this. Okay. And I'll just reload the notebook. Okay. And so I just cleared it down because actually I had multiple tests defined earlier. And okay, so we're back in business. So let's load these definitions again. Okay, so now it's saying attempted to call unbound function Roman add because I've just declared it but not actually bound it to anything. So let's fix that. So we know that our basic implementation is concatenation. So do that and evaluate that and then run it again. And now we're good. So we've got one test, one passing and none failing. So let's add another case with different numerals. Now we've got 2 passing. So that's basically up to where we were before in IntelliJ. Now we're going to add another case. So if we add I, which is 1 to x, and we do it with the I first, what we want to get is xi, because when you display Roman numerals, you do the largest ones first. However, when we concatenate them, it doesn't do that because we concatenate them in the order they're given. So now we need to sort the output. And the way we can do that is find a sort function. I happen to know there's a function called sort by. And of course, it's not an alphabetic sort because, for example, you have, so you've got M is 1000, D is 500, D is 100, and so on. So it's not alphabetic. So we need to have a way of mapping the character in the string to the value. So what we're going to do is we're going to define a map here, and the map maps a character. So in Clojure, this is how you do a character literal. So X is mapped to 10 and I is mapped to 1. Just start with those for now. And then the sort by function. So what's going on here? So we've got a key function, which is the thing that gives us the value we need to sort by. And in Clojure, you can treat maps as a function. So if you pass a value to a function, it will actually look up that value and return the value. Look at the key and return the value. So let's try that. So we're treating our map like a function, and we give it our string xi. So it's kind of working. That's returned a collection with 2 letters in it, but they're in the wrong order because it's sorting them in ascending order. And you can see there's an overloaded version of this function that takes 3 arguments. So in Clojure, you can't overload by types, but you can overload by the number of arguments. And the 3 argument version gives us this comparator argument, and that allows us to specify the order. So we're nearly there. So now we've got the characters in the right order, and we just need to combine them, and we do that by apply str. So apply str takes another argument here, which is a collection, and it's effectively like passing the elements of the collection as parameters to the function. And we've got a bit of Clojure foo here as well. This is called the thread left macro, which takes this expression and threads it into the first parameter of the next function, and then it takes the result of that and threads that into the first parameter of the next function, which is kind of a way of thinking like you're threading data through subsequent expressions, and it's a nicer way of writing code, because actually it's easier to understand and having deeply nested function calls. So let's do that. Okay, so yeah, we're getting to what we want. We've got our Roman numeral results sorted as we would like, and now let's convert that to a function that we can use and test it. Okay, good stuff. So now we're sorting the numerals largest first, and what happened here? So I have, did I actually evaluate that? I did. So now we have a different problem, which is I forgot to include v. So when it's looking up, so we've still got the simple addition test hanging around from earlier, and when it runs, when I do run test, it runs all tests in the namespace, and that test is using v, and v doesn't exist in R. So let's fix that and run the test again, and it's all good. So you can see I've just extended the map to include the value for the v numeral. So I wanted to leave this open, so I'll share these afterwards, and if anyone wants to continue and do the remaining steps, you're very welcome. One of the next steps to consider is how you handle subtractives. So for example, if you're doing 4, it's IV, and if we run our tests, we don't get what we want, because you have to do some pre-processing on the subtractives. And then there's also a further step, which is how do you combine them right to the end. So the example test I've got here, which is commented out, is if you add 502 to 503, you would expect to get 1005, but actually you get something else because it's not combining the different numeral values into a larger value. So that's the end of the Jupyter demo. Yeah, I'd love to get feedback on this. I enjoy coding in Clojure. I think it's a great language to use, and you can have a lot of fun with it. And I think notebooks are a really good way to teach it. So I'm interested to hear what you would like to see. Are there any particular topics that you'd like to cover? What do you think? Yeah, very happy to receive feedback, and yeah, let me know what you think. That's it. Thanks for your attention.
Yeah, thank you very much for that, Andrew. Let me just have a quick look if we got any questions in the YouTube chat. I don't think we did. If anyone has any questions, now is the time to type them out in the YouTube chat, and we'll stick them up. I'll give that a second. Thank you very much for that. That was great. How mature is the kernel for Clojure then in for Jupyter? Because I appreciate that you've kind of got to plug a new kernel into a Jupyter notebook to use kind of a different language with it.
It's so I see lots of people doing Python stuff. I don't see so many people doing Clojure stuff, but actually I think that it's been around for a while, and it hasn't, it's not how can I put it, it's not changing rapidly, so I think it's pretty stable actually, and I've not had any issues with it. Yeah, I mean it seems really solid.
Cool. That's a good answer. So here we go. Here's one question. I'll pull that up. What makes Clojure a more suited language for TDD than other languages?
I wouldn't say it's necessarily more suited. I think there are lots of JVM languages. So I think it's as, I guess what I was trying to demonstrate, I think it's as good and easier workflow as it might be if you were doing, TDD in Java and, JUnit and whatever. So I think the Clojure has other strengths. It's because of the way the language is designed, you can get a lot done with not much code. I think it would be disingenuous to claim it's better at TDD than other languages, but I think it's certainly as good.
Mm-hmm. No, totally fair. And then this one, how long did it take you to get into Clojure?
So I spent a while bouncing around the dojos, and I was, I guess, probably doing it for like 2 or 3 years. And I would like to see more projects in Clojure. I think it's a bit of a supply and demand thing that some managers may have the perception that it's challenging to hire for Clojure, but actually I think there's lots of people who want to learn it. This is a slightly meandering answer, but I probably did 2 or 3 years, and then I got a project. And of course, once you have a commercial project, that helps a lot because recruiters tend to look for shortcuts. So if you want to get into Clojure, there are lots of great resources. There are the dojos. There's Clojure. Clojure for Brave and True is a good starting book. And if join the Clojurian Slack, if you're thinking of learning it, ping me and I'll happy to chuck a load of resources in your direction.
Cool. That's it's a good answer. Keep going for now. How do you measure code coverage with this stuff?
Yes, we have done. I'm trying to think what the name of there is a line again plugin that measures code coverage. I don't remember what it is off the top of my head, but yeah, absolutely.
Cool. I'll probably call this the final question. Are there any assertion libraries for Clojure to help with TDD?
So there's one called Midge, which where you kind of write your test the other way around. So it's more of a instead of having your expected value like an equality assertion, equals expected value expression. Midge kind of does it another way where you like the syntax is different. It's kind of like a DSL in a way. The diff reporting is I think nicer probably than Clojure test. But I mean, you because it's you can write your own functions to kind of do the assertion checking if you're doing a more complex data structure. Just as a general principle in Clojure, breaking things down into smaller functions with good names is a helpful thing to do because that gives you kind of the self-documenting code rather than having dense, hard to understand functions.
Cool. Okay, I think we better leave it there. Thank you very much again for speaking, Andrew. We really appreciate it. Obviously, can't run these minus people, so yeah, thank you very much.
Welcome. Very welcome.
Yeah, I think we have Jorge on. I'm going to bring him on now. Hello, I believe you should be in. Hello.
Yeah.
Okay, I'm going to drop you off, Andrew. Thank you very much. Cool. All right. So, fingers crossed. If you have slides or anything, go ahead and bring those up, and we can get going.
Okay. Let me see if I can. Which one is this? No.
Yep, cool. I've got that. Just bring that up. All right. Yep. Amazing. All right. I'll leave you with it. Once again, thank you to Codurance, as per. Yeah, take it away. Thank you very much.
Well, hello everyone. My name is Jorge Guerguía Garcia. I'm a software crafter of Codurance. And by pure chance, I am joining tomorrow Andrew on his team. So that was interesting. Okay, so since graduating university, I worked around 10 years using C# prior to joining Codurance. Interestingly, since I joined Codurance, I haven't done any C#. I have done quite a few other languages. My main paradigm, therefore, was object-oriented programming. Even the years that I worked in Spain before going to university, I was using OOP, C++, Delphi, BB6. Well, BB6 is some kind of other paradigm, I don't know. I read a lot about how to work with objects. Things like the works of calisthenics, solid principles, design patterns, read the practical object-oriented design in Ruby by Sandy Metz. Basically, everything that I could get my hands on, I read. I just tried to improve always my coding. That doesn't mean it was the only paradigm I was using during those years. It was the one that I was using for production code. On my spare time, I started to dabble with other stuff, including FP. I touched a bit of Clojure, a bit of F#, a bit of Elixir. I was trying to do some katas. I joined SSystem, which you haven't used. It's a superb tool to learn a new language. And then I joined Codurance. And on Codurance, I have my first opportunity to do actual production code in an FP language. In this case, it was Clojure. The application did what it was supposed to do. But in terms of quality, it was a bit of a disaster. Okay? Practicing in any field is important. Practicing with purpose makes you internalize the necessary elements to perform on the field. We usually know it as a muscle memory in sports, in dancing, things like that. This idea that the more you practice, the less you have to think about it. So for us, for programmers, we can call it brain memory. And it is a fact that most of our field, most of programmers, don't beyond, it has been extended a bit more of the idea of doing katas and doing exercises at home, but most people actually only practice in production code. And that's how you end with bad architecture, bad code, and whatnot. You usually learn the lessons for the next job, which is what happened here. Even more insidious, the grown brain memory took over. At the beginning, it was fun. I was able to write some nice Clojure code, but as soon as the time to deliver started to get close, it has a certain constraint because it was for an event that the client was doing on the on specific dates. I started to write as if the code as if I were doing OP or so my OP brain memory took over, which meant that I was created a tangled mass that was difficult to test and to change. In the face of adversity, when you don't have time to think, it's your muscle and your brain memory, the ones that take control. And I'm actually sorry for the colleagues that had to take over and try to make some sense of what was happening in the code. After a lightning talk that I did here in London and some discussion, I was pointed to a blog post that came out of a Socrates session, software craftsman and testing and conference in 2015 that created this idea of having functional calisthenics. The same thing, the same way that you have the calisthenics, you have the idea of functional calisthenics. I read it, and I was not completely happy with some of the rules, and definitely I wasn't happy with the blog post that I read didn't have any explanation of why you had those rules in place. So a few colleagues at Coherence and me got together, and we kind of changed them a bit. And that was my actual first post for Coherence. You can see the link to a post over there. And those are basically the rules that we came with. Now you have a bit of experience with FP. You look at those rules and you start thinking, that's Haskell, which is basically the idea. That Haskell is usually tend to be called the most pure of the FP languages. Lots of things that are over here is try to force you into going into that direction. And these rules over here allow me to practice with purpose. Okay, no, it's not just, oh, let's gonna do some kata or whatnot. I'm doing this kata, I'm doing this exercise at home, and I have to think what I'm doing. Is what I'm doing following these explicit rules? Yes or no? Of course, the rules that we explain that we have over here doesn't mean there are rules that you have to do on production code. It's just the rules that helps you internalize, create that brain memory that I was talking about earlier. And it is so. By the time I was on my next Clojure project, it was much better, much easier to follow what's happening with the code. Okay, so just to show some code about this whole idea, let me see just a second. So this is what I have over here is code. Let me see. Just gonna come back down. I am missing something. Oh no, that's the right one. So you see this function over here, yeah? All this function. And this is how I did create before the code in Clojure. One of the things that I want you to look into is this whole let statement. Okay, all of this. I wasn't happy with the way that this was working. This is just structured programming. Okay, what you have over here is pure structured programming with things intermingled together. Okay, and this is a relatively simple case. There were more difficult code that I have written like this. So the idea was to move away from all these using those rules. On this case, for example, is the idea of eliminating all those intermediate variables. And over here, I'm doing the same thing, the same code as above, but now all that let statement, all that structured programming goes away. And over here, you are linking. You have a function does something, and the output of that function gets linked to the next one. So this is using the threading macros from Clojure. Now, those threading macros, actually, a more general term will be pipes. Okay, and pipes you can use in most functional programming languages, and I do use them. Clojure, SR, LAC, and I think to use them as much as I can. The same way that when I'm working on OOP, the same ideas apply to the different languages that I have used: C#, Java, Ruby, Python. It doesn't matter the language, general ideas about object-oriented programming are the same happens with functional programming languages. Some of the same ideas are the same. And the way that you use maps, collections, reduce, it always works the same in all of them. You have to think about the specificity of each language. Each language will have its edge cases, or will have things that work slightly different. But most of the main ideas of functional programming are the same. As you can see on this specific code, we have in the middle of everything that is happening, we have this client get call, which you can summon that this means that there is an outside call happening somewhere outside of my system. Now in Clojure, it is relatively easy to deal with this using profiles. Okay, and I could have a profile for development that will point to a folder with where I will have just a mock system, a mock call. I can even have some logic on it that I can use for testing, for doing really quick testing. And then I will have a production folder, a production code that is the one that I will be using for integration tests and to actually get the thing live. But actually dislike this approach. It makes it easy to do it. It makes it easy to do it, to be able to put those calls in between to outside systems, but I don't like it very much. So this is something similar, a similar idea of on JavaScript, in which I have, you can see the await statements inside the code, which in Java means that something is going to be happening, probably a call to an outside system, okay, in JavaScript, sorry. And what is happening over here, you can see there is barely any logic within the system, within this call, and all the logic was hidden inside those await calls. The problem with doing that is that, again, testing becomes difficult. Understanding what's going on, it becomes difficult. So now I'm more of the idea of using what Mark Seaman calls the impure sandwich. Or, well, it can be a multi-layer cake, really, at some point. So on those cases, we have code like this. So I have extracted the code, and each await function at this point in time is just the single call to the outside system and return back the data, and there is no logic within the system. And suddenly I see that I was doing a lot of things within these calls. So an await was basically having another 2 or 3 awaits inside. Now my system is far more defined, in which I have some outside call, some logic being done, which has been assigned to a function, of course. Another outside call, more logic, outside call, logic. Now, all the logic is easily testable. I don't have to create mocks. I don't have to do anything special. And this, which becomes the code that you see over here, now becomes basically this my root. So you have done a dependency injection on object-oriented programming. That's your dependency injection root. That's the same idea over here. This is the root of my system, where everything gets put together, and all the calls happen here, all the external calls, and then I have my small pieces of logic that I can easily test. This root part, it gets tested with an integration test, with an end-to-end test, whatever is appropriate for what I need to do. So this is just a couple of examples of thinking modified of how I do things by the rules that I had on the functional calisthenics. But the fact that now I'm not just throwing things out, I mean, just hacking some code, and I'm actually thinking about what I'm doing. And because I'm thinking what I'm doing, I start to look and see patterns on what I'm doing and why I'm doing things. And that's it for my quick talk.
Cool, cool. Let's have a look if we've got any questions at all in the chat. If anyone has any questions, please feel free to stick them in the chat. Give that just a moment. Yeah, thank you very much again. Yeah, that was interesting, definitely. 1 second, I need to find my slides as well in readiness. Cool. Just wait a second more and see if there's any questions. If there aren't any more questions, then I imagine you've got Twitter there, so people can come and find you via Twitter if they want to. No one's putting any questions in, so let's call it at that. That is fine. Thank you very much again. Thank you to co-durance. I shall take you off now, and I'm going to put my slides back on. All right, so there we go. Cheers. Thank you very much, Jorge.
Yeah.
All right, cool. That is what we've got for tonight. So as I mentioned before, we've now got a Discord channel, which, I mean, we're calling it the pub. It's not the pub, but it's the closest thing to the pub that we're going to get. Some of us are going to be on there. A bunch of us that are the organisers are already. Make sure that you press the thumbs up on the rules page when you get on there to accept. That then gives you the access. As I say, if there's any problems, we'll have a look at that. There's always voice chats and stuff like that if anyone does want to do anything like that, but just generally come and hang out with us. We're hoping to run some more of these. I appreciate that we've been kind of absent for the last few months. I don't think we really knew exactly what it was that we were going to want to do with the meetup if it went online. Well, if it had to go online, but obviously the unpleasantness continues, and so we kind of had to get going with online. So we are looking for speakers. If you want to speak, please drop us an email. It's lambdaloungemcr@gmail.com, or tell us on the Discord, or just generally find a way to get in touch with us. We're very, very interested in picking up any speakers. Thank you again to the speakers. Thank you again as well to co-durance. And yeah, cheers for coming and spending an hour and 18 minutes on listening to functional programming talks. All right, I'm going to leave this up for 30 more seconds, and I'll hop off. But yeah, join us on Discord. Thank you very much, everybody.